Okay, so let's see how you did here. So the average rate of change remember, the formula is f of x2 minus f of x1 all over x2 minus x1. So when you substitute in these values, we've got 1 over negative 1 minus 1 over negative 4 all over negative 1 minus negative 4. Then we simplify this, we get negative 1 plus a quarter over negative 1 plus 3, which gives us negative 3/4 over 3 over 1 and when we divide fractions we flip and multiply, so we get negative 3/4 times 1 over 3. And a little bit of simplification, we get negative 1 over 4. So the average rate of change of the function m of x equals 1 over x on the interval from negative 4 to negative 1 is negative 1/4. Okay, so now the instantaneous rate of change, those we're going to be estimating, of course, the estimated instantaneous rate of change. We start out with the average rate of change formula again. I'm going to have to really squeeze this in tight because it's going to be fairly lengthy. So the average rate of change is 1 over a plus h minus 1 over a all over h. And when you have 1 over a plus h minus 1 over a, we got two fractions. We're subtracting here, or adding the negative of one fraction to the other. We need a common denominator. So I'm going to determine that the common denominator is a quantity a plus h. And so then multiply top and bottom of the first fraction by a, multiply top and bottom of the second fraction by a plus h. I know you're not really going to like that, but I'm sorry. This is the way it goes sometimes. So we're going to combine these. We've got a minus a plus h all over a quantity a plus h. Multiplied, and I'll bring up this h to 1 over h here. And then I'll simplify the numerator. So we get a minus h. These will disappear here. That, of course, is over a plus h from the first fraction multiplied by h. So we get negative h over a times a plus h times h. The h's cancel here and here. And then we're left with negative 1 over a quantity a plus h. So that's the average rate of change. Okay, so this is just all algebra stuff, really. It's nothing, not really rocket science, not yet anyways, we'll get there. Now, when we decide that a equals negative 1, we'll substitute that in. So this thing is negative 1 over negative 1 times negative 1 plus h. The two negative 1's will cancel each other out. Again, quite convenient. And so then we're left with 1 over negative 1 plus h. So this is now the simplified form of the average rate of change. So we're going to come up here and we'll say, okay, the preceding interval we let h equal negative 0.001, and in the following interval, I let h be positive 0.001, and then again, the average rate of change is still just average, is 1 over negative 1 plus negative 0.001. Over in the following, it's 1 over negative 1 plus positive 0.001. For the h value, which is that little tiny horizontal distance between the value of interest of negative 1 and the next value beside it. And so we're left here with 1 over negative 1.001, which is negative 0.999, 000, 999, etc. And this is going to be 1 over negative 0.999. And when you divide that, you get negative 1.001, 001, 001, etc. So then finally, the estimated instantaneous rate of change is, so we're going to take these two things together, negative 0.999, sorry, negative 0. Yeah, that's right, plus negative 1.001, average them, and we get, after a bit of simplification, negative 1. So that is a kind of tricky, but it's all just kind of algebra. You just kind of have to make sure that you keep track of all your variables in terms of that. So that is how to calculate the estimate of the instantaneous rate of change of the function 1 over x when x equals negative 1. Let's move along to the next example.